I got 5 dead grandmothers, and I got 6 flat tires, and my computer broke, and no, not going to extend it. So when I do set the dates, those are the dates. So for the 4 or 5 people that are not pulling their weight, I don't want to hear it. I don't want to hear it. Now, most of you, 80, 70, 80% of the class, you're doing what you're supposed to. So I'm not talking to you. But the rest of y'all, the 4 or 5 that I mentioned, I didn't mention their names. I just said y'all wasn't doing squat. You're not doing squat. So you need to get on. You need to get on with the program. All right, that takes care of that. I hate to do that, but I have to. Let's go to the emails, and let's go. I'm going to present screen, and I'm going to pull up Math 155. I only got 2 questions to go over, and then we're moving on. So I'm going to present screen and pull this back up. And somebody, let's see. Okay, I'll be honest. I had to go back like a week ago and read the info that you gave out at the beginning to realize that there was actually homework to do. Well, good. You read. Wow. Let's highlight that. You read the info that you gave out. What a concept. You're the one that actually read the info. Interesting. You know, I actually had somebody email me last night, and they wanted to know how to get to the YouTube videos. I told them to check their handouts. Maybe I shouldn't give out any handouts, and then y'all won't ask any questions. If I don't give out any handouts, then you won't ask any questions. There is one handout. Let's go look at it. Here we go. There's one handout right here that says what? What is the first word of that handout? YouTube. Not in this class. It was another class. All right. This is 5.3, 51, and 99. First of all, 51 is number 22. Is this a test question? That's my first thing I tell y'all. Is it a test question? No, it's one of those that we did. I think this is, somebody count how many we've done. I think this is probably the 6th or 7th problem I've done with this. It is not a test question. I don't think it is. Sometimes the computer will put a test question on there like that, but I don't usually pick those questions. So let's do it. How was everybody's weekend?
Very good.
It was wonderful.
Well, finally got the NASCAR race out of the way last night around midnight. And I watched the golf tournament yesterday. And I think I watched a little bit of it Saturday. That's, you know, and then worked on the farm. You can't do much on the farm in the rain. So fed all the cows and animals and stuff. That's about it. Didn't do anything really interesting. All right. So 0.7, x is equal to 0.7. So since that is in the 10th place, I'm going to multiply by 10. And I get 10x is equal to 7.7, and that 0.7 is repeating. Now, I'm going to take these 2 equations and I'm going to subtract them from each other. So 10x is equal to 7.7 repeating, and I'm going to subtract 1x is equal to 0.7 repeating. And what happens that we want to happen? What happens?
The repeating numbers cancel each other out.
The repeating numbers cancel. Miss Grindle, you must be the one. You must be the one that's actually listening in class. I'm just kidding. All right, so that's going to be 9x is equal to 7. And divide by 9. And x is equal to 7/9. Now, is this a standardized test question? Oh, hail to the yeah, it is. So make sure you write it down for those of you that are going to be taking the T's or the GRE later on for doctorate programs or entry exam for, I don't know, whatever. A standardized test will have this question on there or one like it. So how do you check it? You take your handy dandy calculator and you do what? Divide 7 by 9. So let's take our handy dandy calculator and take 7 divided by 9. And you should come out with what you started with, 0.7 repeating. And you feel good about yourself, right? So I'm going to type 7 divided by 9. 5.3, number 99 in the book, number 38 online. First of all, is it a test question? I'm surprised I hadn't seen the step question. Okay, this one's close to it. Yes, this is a test question, and it also is a standardized test question. The instruction for assembling a computer stand includes a diagram illustrated with these dimensions. Find the total height of the stand. Note the symbol in shorthand for inches. Okay, looks like you're going to add these 3 up. So I'm going to go over to my handy dandy whiteboard. I'm going to write these down while y'all are writing them down. 6 1/4 plus 29 1/2 plus 24 3/32. I'm not going to have enough room, so I'm going to rewrite it. Now, I'm not going to look at the rest of the problem because I don't need to see all that, because all I'm going to do is add those 3 up. So I'm just going to go ahead and write it down again. 6 1/4 plus 29 1/2 plus 24 3/32. Well, I'm adding, so I got to get a common denominator. 2, 4, 32. Now, I promise y'all, I've got a degree, I've got most of my teeth, and I've got running water at my house, okay? I know that the common denominator is 32, but some of you don't know that. So you go back to what you know, the prime factorization and the greatest common divisor. 2, 3, 5, 7, 11, and sometimes 13. So 2 will go in there. That'll be 1, a 2, and a 16. 2, 1, 1, 8. 2, 1, 1, 4. 2, 1, 1, 2. 2, 1, 1, 1. And 2 to the 5th power is 32. So 6 32s, 29 32s, and 24 32s. Now let's convert. How many times will 4 go into 32? I'm asking y'all.
8.
8 times 1 is?
8.
8.
Y'all are interacting. I feel so special. 2 will go into 32. How many times?
16 times?
16 times 1 is?
16.
32 will go into 32.
1 time.
1 times 3 is?
3.
Miss Grendel, you sound like you sick.
I am. I got my son's cold.
Okay. You got the COVID is what you got.
I've already had that.
I've already had it too. And my son gave it to me.
Same. I got it from my husband's work. He brought it home to us one day.
My son's 14. We drink out of the same beer keg, and he must have gave it to me. All right, that's a joke. That's a joke. All right, so now let's add up. What's 6 plus 1?
Sorry.
No coughing in class. 6 plus 29 is what?
It's 35.
35, Hubert. Yeah, that's good. Thank you. And what's 35 plus 24?
It's 59.
Okay, so we add those up, you get 59. And I'm going to put over here 8 over 32 plus 16 over 32 plus 3 over 32. 59. And 8 plus 16 is 24. Plus 3 is 27 over 32. Now, you can try to reduce that, but what's the only thing that will go into 27? 3 times 9, Hubert. That's right. So 3 will not go into 32, and 9 will not go into 32. Chances are, now, you could, if you wanted to see what this was in real life, this is what you would do. Well, that's 59. And the closest thing to 27 or 26. Now, you could use 26 or 28, whichever one you want to. I'm going to use 28. I'm going to put a dot here and a squiggle. That means I'm guesstimating over here. And now I know 4 will go into these two, right? So that's 59 and 7/8 inches. So we know that the answer, 59 and 27 over 32, is close to what? Almost 60 inches. So this, of course, this is the height. That's a regular equal sign right there. But if you was to guesstimate it, I would say 60 inches. But that's not the answer. That's a guesstimate. This is the answer. Okay. And if you use 6, that would be what? 26 over 32, 26 over 32, 59 and 26 over 32. Well, that's not really going to help. 2 will go into both. That would be 59 and 13 over 16. That really don't help you because most people are used to seeing 7/8. 7/8, if you use wrenches, 7/8 is close to an inch. And for those of you that don't know what a wrench is, I'm not going to tell you because your parents, it's their fault. You can't start a revolution if you can't make a ham sandwich. You need to learn what wrenches are. All right. Question, right, complaint. So our answer is 59 over 27 over 32. 59, 27, 32, which that tells you nothing as far as common sense. This tells you is close to 60 inches. Now, you don't have to do any of that. That's just me teaching you what this is close to. It's close to 60 inches. You feel good about yourself? I hope so. So 59. Go ahead. What's your question?
So this was my problem. When I did this, instead of adding the bigger numbers and then the fractions after that, I turned my mixed numbers to improper fractions, which gives me the wrong answer.
Okay, you did what now?
I made my mixed numbers an improper fraction.
Okay, I will do that for you. Hold on a second. You can do it that way. Just it's more tedious if you do it that way. But we'll
I think
do
that's
it.
what I did too.
Okay. Okay, well, they say I'm wrong, which I don't believe it. So it says right is a proper fraction or mixed number. So I don't know what I could have done differently. Let's do it improper and see what we get. So the 6 1/4 plus 29 1/2, you'll get the same answer, plus 24 3/32. So I'm going to take my handy dandy highlighter pen. I'm going to draw I like to call it the big C. That's what I tell all my basic math students when I used to teach basic math. And 6 times 4 is what? 24 plus 1 is 25/4. Plus 2 times 29 is 58. 58 plus 1 is 59. Everybody with me?
Yes, sir.
Yes.
And 32 times 24. We're starting to see why this can be more tedious. What are you going to have to depend on here? Your brain or what? The calculator. Well, I'm not going to use a calculator because I've got a brain. So 30 times 24, that will work a little bit better. You could use 25 times 30, but that wouldn't work too good. We know that 3 times 24 will give us a what? 3 times 24 will give us 82, I think. Let's see, 24 times 3. That's a 2 and a 1. 3 times 72, I'm sorry. So I know that 24 times 30 is 720, and then 2 times 24 is 48, so that'd be 768. So 768 plus 3, somebody check on your calculator 32 times 24 for me and make sure it's 768.
That's right.
768 plus 3 is 771. Please check me.
Yeah, 771.
Now, do y'all see why I didn't use improper fractions? Because
you got them big numbers to deal with.
You get into BA numbers. All right. Attitude, big attitude. Do you know somebody actually complained that I used the word ass in class? So I had to start using attitude, even though ass is a donkey. But anyway, 2, 4, United States of buttercups. 2, 3, 5, 7, 11, and sometimes 13. We did all that. 2, 1, 2, 16, 2, 1, 1, 8, 2, 2, 2, 1, 1, 1. Do, do, do. And we found out that 32 is our common denominator. 32. Does everybody see what happens? What's going to happen now? We're going to get BA numbers again. 4 will go into 32 8 times. 8/4 is $2. And I bet somebody, tell me this. Why do you go 8 times 25? You use a calculator, but if I asked you what 8/4 is, you tell me it's $2. 2 will go into 32 16. I ain't even going to try it right now, but that's 16 times 59. I'll tell you what I'm going to do, though. I'm going to take, let me write 771 here. That's close to 60. So I'm going to take 60. Let's see, 6 times 6. That's going to be 960. 960 minus 59. I'm sorry, 960 minus 16. Hold on a minute. 960 be 44. 944?
That's right.
Something, 943. What is it?
It's 944.
944? So I was right. Oh, I'm sorry. I needed a calculator.
Oh.
Y'all check me. What is 15 times 59? 16 times 59. Make sure it's 944. 200 and 771. Does everybody see why I did mixed numbers?
Yeah.
All right. So 200, that's 1144. 11, that's 18. 19, I don't know. 19, 11, 19, 15. What is it?
1915.
1915 divided by 32. Knock yourself out. I'm not going to divide that. You do it. Somebody tell me what you get. But now you got to figure out. Let's see. Wait a minute. I don't know if it's divisible by. I'm trying to see this divisible by. I know it's divisible by 5, but 32 is not. 2 will go into 18. I meant there, go in there 9 times. 5, no. 3 won't go into 32. 5, 2, 3, 5, 7. 7 will go in there 2 times. 2 times will leave 51. I think 7 won't go into 32. So I don't know. What does this come out to be? What's 1915 divided by 32?
It's like 59 and a bunch of other random numbers.
59? We
Yes,
know it's
sir.
59. So somebody take 59 and multiply it by 32. Tell me what you get.
1,888.
1,888. 1915. 15 is 7. 10 minus 8 is 2. I got 27 over 32. Y'all check my math. I believe I'm off 1. That's why I marked it wrong. I must have done my math wrong somewhere. No, I got 27 over 32. I got the same answer. Y'all check my math on this one. But you can see that I did a whole lot less big numbers when I did mixed numbers. Actually, I was through with it right here. So I don't know why I didn't like my answer. I bet I know why. Because I didn't hit the mixed number key. I bet you $1 that's it. So I'm going to delete this. And I'm going to hit the mixed number key. And now I'm going to type it in. 59 and 27 over 32. And it's going to have to be the height. They're asking for the height, right? It's got to be inches.
Inches.
So that should be the answer. Yeah. I didn't hit the, you got to hit the mixed number key. So if you did that on a test, would I count it wrong? No. If you had 59 and 27 32s and it marked it wrong just because you didn't type in the mixed number key, I would mark it right. 2 good problems. All right, now let's move on. 5.6. Now, before we move on to 5.6, I want you to go into properties, exponential properties, and I want you to make an index card. Find one. Find exponential properties. I'm trying to find one for you. There you go. There's a good one right there. Now, of course, you don't have to do this because only 2 of y'all are going to make an index card. So I'm going to make it for you. I'm going to save this. And I'm just picking that one. I'm going to call it properties of exponent. Send my pictures. Go to, oh, I'm not going to do it for you. You know, I'm not doing that. I'm going to show you how easy it is to make an index card. Go to word processor. You don't have to, I'm going to do it as landscape, layout, orientation, landscape, and insert picture. A lot of work here, a lot of work. I don't know if y'all can handle it or not. And look for that, what I just called it. And it was called Properties of Exponents. There it is. And just make it as big or as wide as you want to. Now, for those people that are not going to do this, go ahead and write it down, because I'm not going to repeat it after today. So go ahead and write those exponents down, the exponential laws. And we're going to go over a couple of little ones right quick before we get into scientific notation. Because I'm going to test you on scientific notation. I'm not going to test you on these because you're going to use these to do scientific notation. So if you don't know them, you're not going to know how to do scientific notation. And plus, you learn these in pre-algebra or English or Math 101 or Algebra 1. All three of those classes teach these exponential laws. So write them down. I'll see if I make it a little bit bigger for you. Let's see, how can I make it? Well, I don't want to distort it. Oops, sorry. It might be under view. Well, there you go. You're welcome. Let me take it down to 175. This way it doesn't distort as bad if I just open it up. There we go. And the reason I'm giving everybody, and that's, I'm also doing this for the video for the one or two people that watch the video. That way you can write it down. So everybody has the way to write this down on the index card. And you better learn them because, like I said, if you didn't learn them in 101 or whatever, Algebra 1 or pre-algebra, if you didn't learn them there, you might be having a problem with me in exponentials, or not exponential, scientific notation. Okay, so you got your power rule, which means you add exponents. You got your quotient rule, which means you subtract exponents. Where's subtract? Okay, they didn't put the quotient rule. There it is. Subtract exponents. You got your power rule, you multiply exponents. You got your distributive law, which is basically if I have something in parentheses, I can distribute the power. That's what they're saying right there. It's really the distributive law of exponents. If I have a negative exponent, I can flip it and make it positive. Any exponent to zero, any number to the zero power is 1. And the inverse power rule says I can distribute that m with anything inside the parentheses, just like with here. That's called the distributive law of exponents. So all of you should be saying to yourself, oh yeah, I remember seeing those. Well, that's what everybody should be saying. If you don't remember them, then you need to make an index card. I think everybody needs to have an index card of this, just like I told you to make an index card of other things. These are important. So now, what else do I need to show you? Well, there's a couple of things that I want to show you besides the index card before we get into exponents. And that is, and this is a homework question, it's a test question, and it's a standardized test question. And if you do it on your calculator, it will do the exact what I'm fixing to show you. If I give you -2 to the second power, is that the same All right, this is basically the question they would ask you. Are these two the same? You got a 50-50 shot. That means I want somebody to guess. I heard somebody say no. Let's see who that is because I can't see their name unless I hover over them.
Me, Sarah.
Miss Nelson, or I'm sorry, Mr. Nelson or Miss Grindle. Both of y'all, I think, said no, or somebody. Mr. Nelson, what did you say?
I said no.
Okay, both said no, so they are correct. It is not the same. Let's type it in the calculator. Because you don't believe Hubert, because he's crazy. All right, so -2 raised to the second power. And parentheses, -2 raised to the second power. Oops, sorry, hold on. Raised to the second power. Not the same. Why? Because -2 is this. -2 to the second power is equal to -2 times 2, which is equal to -4, which is equal to -4. Whereas -2 raised to the second power is equal to -2 times -2. And what's -2 times -2? Positive 4. Oops, I'm sorry, y'all can't see that. So make sure you make a note of this. This is not the same as this. You will see that on a standardized test. You'll see one of them, and you'll see it on my test too. I think on my test it's -7, but it regenerates either -2 or -7. So -7 squared is equal to -49. -7 quantity squared is equal to 49. That's another example. So make sure you understand that as far as exponents. Also, let me write this down for you. The square root of x to the first power is equal to x to the 1 over 2. Now this is for your information, meaning you're not going to be tested on it, but you're going to see it on a standardized test. Do another one. The third root of x to the 5th power is equal to x exponent over index. And you got to write that down. Exponent over index. I can rewrite a radical as a rational exponent, or I can write a rational exponent as a what? A radical. So that's kind of like for your information. You're not going to be tested on this, but you might see it on a standardized test. It's called a rational exponent. This right here is called a rational exponent. Y'all learning so much in here. Okay. So, why do we need to know the exponential laws? Because when you do scientific notation, you use these exponential laws. Now, scientific notation, there's two parts. The first part, everybody knows how to do. Okay? The second part, they know how to do it till they get to a certain point and then they blow it. That's the two different types of scientific notation. So let me show you the one that everybody knows how to do. Scientific notation, first let me give you the definition. Scientific notation is placing the decimal to the right of the first number greater than 0. That's scientific notation. Now, I would highly suggest that you learn that definition. Now, is that a book definition? No. It is a Hubertism definition. Well, Hubert, how do we know? Which way do we read?
Left to right.
So 0.000317 and 1,432,700. Okay, so which way do we read? Left to right. So where is the first number in this one right here? Greater than 0. Where is the first number greater than 0?
Number 3.
3. So you're going to put the decimal right there. I love when people go, well, I thought the 7. Okay, so you're from the Middle East. You read from right to left. Masalama. Why would you start with the 7? You don't read right to left. You read left to right. Oh, well, Hubert, when I get into math, I do everything opposite. Yeah, that's what the answer is. I don't know why people say they start from over here when they've been reading for 12 years at least from left to right. Now, those of you that grew up in the Middle East, I excuse you from that because they read from right to left. But here, left to right, the first number is 3. What about here? Where is the first number greater than 0?
1.
So you put the decimal right there. So here we go. Let's move this decimal. 1, 2, 3, 4. So I'm going to change it to 3.17 times 10 to the blank 4. And 1, 2, 3, 4, 5, 6. 1.4327 times 10 to the blank 6. Now, why did I write blank 4 and blank 6? Because these humps and these humps, H-U-M-P-S, or these jumps, or whatever you want to call them, that's distance. And distance is never negative. Okay? But I'm going to ask a mental question right here. And I'm going to put it in blue because I want it to be very, I'm going to ask myself, so first of all, what does mental mean? Mental question, what does that mean?
You're asking yourself.
In your head. You're asking it in your head. Which way do I move the decimal to get original? Here's the original. I'm going to mark it in blue. That's the original. That's the original. Here's where the decimal is right now. Here's where the decimal is right now. Which way do I move this decimal to get it back to look like this?
Would you move it right?
Which way do I move this decimal to get this to look like this?
Left.
Left.
Ooh.
Which way do I move this decimal in my head to get it to look like this?
Right.
To the right. Now, a lot of people say, well, that's not the way I was taught. Well, that's fine. When we get to the second section where people blow it, just see how you do on that. And if you do it okay, then you're good. If you don't, then your way is broken. All right, so this is what I do, and that's the answer. This is the answer in scientific notation, and this is the answer in scientific notation. I ask myself mentally, which way do I move this decimal in my head to get it to look like the original? That's what I do. Now, will you see this in any book? No. This is the way I learned it as a student, because the way I was taught as a student, it was confusing. Okay, especially when you get to the second part, when you add, subtract, multiply, and divide by scientific notation. So I started doing this, and I've been teaching it ever since, and students learn it a whole lot better if they don't know how to do it. If they do know how to do it, then it ain't broke, don't fix it, you keep doing what you're doing. But if you never understood it, then you try it this way. Mental question. Which way do I move this decimal and this decimal in my head to get it back the way it was? Here, I got to move mine to the left to get it to look like this. Here, I got to move mine to the right to get it to look like this. This will help you in the blow it part. And I'm going to show you a blow it question. And we're going to go over those probably Wednesday. Okay? I'm going to go ahead and get you started on one. Now, I'm not going to show you addition and subtraction. Addition and subtraction is easy. You just got to find common, they got to have the same label. To add or subtract scientific notation, you just have to have like terms. Okay, we'll get to that later. I'm not going to worry about these two. I'm going to worry about multiplying and dividing. Multiplying and dividing. Multiply, you have to use the product rule of exponents. And quotient rule of exponents. Okay, so you're going to have to go back and learn that rule, product rule and a quotient rule. Product rule, you add the exponents. Quotient rule, you subtract the exponents. And we'll learn this later, because these are the ones where students blow it. They don't blow it with writing and rewriting. That's not where they blow it. Right here is where they blow it. So let me give you an example. Let's go with 2.3 times 10. No, let's make it 2.0. 2.0 times 10 to the 5th power multiplied by 3.0, no, 5.0. 5.0 times 10 to the 8th power. So I'm going to rewrite it because I screwed it up. 2.0 times 10 to the 5th times 5.0 times 10 to the 8th. All right, I want you to take a second, because it only takes you 5 seconds to do it. But take about 10, 15 seconds to do this problem. Do not use a calculator. You do not use a calculator for these, because that's the whole point of using scientific notation. So what's 2 times 5? Well, that's 10, Hubert. And what's 5 plus 8? 13? Are we done? Yes or no? You got a 50-50 shot. Are we done?
No.
No.
Yeah.
Why are we not done? Because scientific notation says decimal to the right of the first number greater than what? So 10, where's the first number greater than 0? Right there. So that's going to be 1.0 times 10 to the 13 blank 1. Which way do I move this decimal in my head to get it back the way it was? To the right. And your answer is 1.0 times 10 to the 14th power. So where do students blow it? They put a minus right here and they get 12 and they do 90% of the problem correct, but they get the last 10% wrong because of that one sign right here. Okay, so let's look at a division problem, and I only got like 4 minutes. So, and I'm not expecting you to be able to do them tonight, even though some of you that's had the material before, you're welcome to go try it. This is kind of an introduction for Wednesday when we do actually do some problems. How about this one? 45 times 10 to the 6th divided by 3 times 10 to the negative 4th. Okay, we'll give you a few seconds to try to work it. Shouldn't take no more than 20, 30 seconds to work it. Because I don't know what people know and what they don't know. I don't know. I may have 20 people in here that know how to do it and 10 that don't. All right, somebody tell me what 45 divided by 3 is.
15.
That's 15.
10 to the 6 minus a negative 4. 15 times 10 to the 10th power. I guarantee you somebody got 2. Somebody got 10 to the 2nd power. Well, you already got it wrong because you didn't do you didn't turn those 2 negatives into a plus. Now, the first number, we got to move that decimal right there. It's right there, so we got to move it one place. So that'd be 1.5 times 10 to the 10 blank 1. And which way do we move this decimal to get it look like that? To the right. So that would be 1.5 times 10 to the 11th power. And that's where we're going. Out of 5.6, 80% of your test material from 5.6 will look like these 2 questions.
Got a minute.
I know. Division and multiplication. That's what 80% of material that comes out of 5.6 on the test will be. It'll be multiplication and division. We'll do some more of these Wednesday. Now, let me look at the roll right quick, and then you can leave as I check the roll. If Tri-County hadn't logged me out, which they probably have. I logged on right before class. I restarted the computer and I don't believe it. They hadn't logged me out. It's a miracle. They must have forgot. All right, 155 attendance. I'm going to turn this off and turn the recording off.